All right, everyone, we were dealing with a tricky problem. The problem was how to get the Scratch to rotate, to cycle through this list of monsters so that at level 1 it gives us a ghost, at level 2 it gives us a bat, level 3 gives us a monster, but at level 4 it goes back to giving us a ghost, level 5 a bat, level 6 a monster, level 7 a ghost, and so on. And we set up a little bit of a structure here where we said, okay, we're gonna find something that finds our place in the enemies list and gives us the right number, puts it in this variable here, place in enemies list, and then we use that to find the monster. So the idea was, once we define it, if we're at level 1, then this will turn place in enemies list to what? If we're in level 2, place in enemies list will be 2. At level 3, place in enemies list will be 3. But at level 4, place in enemies list will be 1. And back to 2, 3, 1, 2, 3. So by using this to consult our list, we'll get the ghost bat monster, because it goes 1, 2, 3, 1, 2, 3, 1, 2, 3. So as we go through the levels, it will go ghost bat monster, ghost bat monster, ghost bat monster, 1, 2, 3, 1, 2, 3, 1, 2, 3. So we just need to define this, but it's tricky to do. So I'll make a start by grabbing a little function you might not be familiar with, and this is the mod function. Now, the mod function, you kind of know it, but you don't often get introduced to it under that name, but it's very common in computer science. The mod function is basically the remainder function. So if I ask you, what is 9 mod 2? Then what you do is you divide 9 by 2 and tell me what the remainder is. So 9 divided by 2, well, 4 2s are 8, remainder 1. So 9 mod 2 is 1. What's 9 mod 1? Well, it's going to be 0, right? Pretty much every whole number, mod 1 is 0. Because 1 goes into everything perfectly. What about 10 mod 1? Well, that's 0. What about 10 mod 2? Well, that's also 0 because 5 2s are 10, there's no remainder. So 0, 0 remainder. What about 10 mod 3? Well, then it's remainder 1. 3 3s are 9, and then you get remainder of 1. What about 11 mod 3? Well, that's going to be remainder 2, because 3 goes into 11 3 times with remainder 2. So hopefully you get the idea of what the mod does. Some tricky cases with mod is when you don't get anything. So for example, what if I ask you, what's 2 mod 3? Well, you got to divide 2 by 3. Well, 3 doesn't go into 2 at all, which is the same as saying it goes in 0 times and leaves a remainder of 2. So 2 mod 3 is 2, because 0 3s are 0, remainder 2. Similarly, 1 mod 3 will be 1, because 3 doesn't go into 1 at all. So 0 3s is 0, remainder 1. Okay, so we're going to use this to try and get this pattern 1 2 3 1 2 3 1 2 3. So here's an attempt. Suppose that I grab the level variable and I stick it in here. Then what do I get? Well, I almost get what I want. And so I made a little thing here. So I almost get what I want. So at level 1, so what I want is 1 2 3 1 2 3 1 2 3 1 2 3. What I actually get from this level mod 3 is 1 2 0 1 2 0 1 2 0 1 2 0. Which is almost right, but it's not quite right. Let's make sure we understand why it gives us this pattern now. So at level 1 mod 3, well, 0 3s are 0, remainder 1. So it gives us 1. At level 2 mod 3, well, 2 divided by 3, 0 3s are 0, remainder 2. So it gives us 2. But at 3 mod 3, well, 3 does go into 3. Goes in 1 time. These are remainder of 0, so we get 0. Then we get to 4. And we have 4 mod 3. Well, 1 3 is 3, remainder 1. It gives us 1. 5. 3 into 5 leaves remainder 2. 6, 3 into 6 leaves remainder 0. 7, 3 into 7 leaves remainder 1. 8, remainder 2. 3 into 8, remainder 2. 3 into 9, remainder 0. 3 into 10, remainder 1. So you can see how we've almost got the right pattern. Instead of 1, 2, 3, 1, 2, 3, 1, 2, 3, we've got 1, 2, 0, 1, 2, 0, 1, 2, 0. So we just need to fix this, and we'll have the function that we want. So I'm going to leave that till the next video, and I'll see you there.
Thank you for listening, and if you find this video useful, please hit like and subscribe.